3 space and the 1-time dimension, but it can actually be extended to include more spatial dimensions pretty easily. And by easy, I mean it's not really that easy. It's not like 1, 2, 3, 2 plus 2 math, but it's allowed, it's allowable. Okay? So under the modest assumption of one extra space dimension, Kaluza carried out the mathematical analysis and explicitly derived the new equations. So Kaluza, as a good student of general relativity, which by the way most, if not all, string theorists are, they start with general relativity and then they extend it. That's really what's going on. He found that in the revised formulation, the equations pertaining to the 3 ordinary dimensions were essentially identical to Einstein's. This is another thing. Once you extend general relativity to have, say, another extra dimension, you still have to prove out Einstein's work and show that in your new theory, Einstein's work is all still valid, right? If the equations don't look like something totally different or give you a different kind of universe, then that's not good. You should be able to explain the general relativity universe. It should fall out smoothly from your new theory, okay? Because again, remember, the whole point is to unify GR with quantum and explain all of that with one theory. So if your one theory cannot explain some part of what is already known, then you would look very bad, okay? So that's what's going on. But because he included an extra space dimension, not surprisingly, Kaluza found extra equations beyond those Einstein originally derived, which makes sense. So extra dimensions means extra equations, extra math, got it, right? It's fine. After studying the extra equations associated with the new dimension, Kaluza realized that something amazing was going on. The extra equations were none other than those Maxwell had written down in the 1880s. So in the 1800s, that was a great time for electromagnetism to have leaps and bounds of progress by, of course, people like James Maxwell, Michael Faraday, etc. So anyway, you might be familiar that Maxwell has given us the equations of electromagnetism, but when he did this extra dimension thing, he got Maxwell's equations for describing the electromagnetic force, which was very exciting, very, very exciting. And they all kind of knew that Einstein, a grand unified theory should basically spit out GR, electromagnetism, quantum mechanics, all of this, right? So isn't it so great when that starts to happen? So that's another thing when somebody pointed out, is string theory just a fake news or sort of a fiction? Well, the thing is that they wouldn't have, for example, at the point at which we are right now, Kaluza Klein, right? They wouldn't have progressed things if they didn't see some hints of nature and some other things being able to get pulled out of doing this extra dimension stuff. If the extra dimension stuff led to total nonsense, then they wouldn't have carried on with it, right? So that's part of it too. It's that they did see some light at the end of the tunnel, otherwise they wouldn't have gone in that route, because nobody's trying to look stupid or crazy, right? So by adding another space dimension, Kaluza had united Einstein's theory of gravity with Maxwell's theory of light, which is a great success. So imagine, I mean, if that was your PhD thesis, for example, and you did some crazy thing, and by crazy I mean in a good way now, say you took Einstein's equations, you added one more dimension, and somehow you got Maxwell's equations out. I mean, that would be pretty impressive. That would give people pause to think like, oh my gosh, like, is this how, is this what's going on? Like, is there an extra dimension thingamawitch that we don't experience? And then if you consider it, you get one more theory out, and here's your grand unification of at least GR with electromagnetism. Now all we have to do is to also unify quantum mechanics, which is the strong nuclear force and the weak nuclear force as well. And maybe if that can come out too, we would be really happy. So this is sort of like people got greedy for the theory of everything. It's like once you start to see that something is working out in one way, which is the electromagnetism thing, you get greedy for a theory of everything. What if we got a theory of everything out, right? And now, I'm not saying that things didn't get much more complicated with that. Definitely it did. But you can kind of see the train of thought here, and people have to follow their train of thought once they see that glimmer of